Imagine it's your first day as DevOps engineer. Your project manager walks to your desk and says, "We are starting a brand new application. No servers, no cloud, no CI CD. Where do you even begin?" Most engineers think the answer is Terraform or Docker or some even things Kubernetes. But that's not where experienced DevOps engineers start. Let me show you what actually happens in a real project. Before touching Azure, AWS, Kubernetes, you first need to understand why you are building the application. And you have to start asking questions like, what kind of problem are we solving? Who will use this application? Is it internal or public? How many users do we expect? Is downtime acceptable? Are there any security or compliance requirements? Imagine you are building an internal HR portal for 100 employees. Now, compare that to an online shopping platform serving millions of customers. Would you build them the same way? Of course not. The business requirements determine the technical architecture. That's why experienced DevOps engineers spend time understanding the business before even thinking about the infrastructure. Now it's time to understand the application itself. Meet the developers, ask questions like, what programming language are we going to use? Is it .NET, Python, Java, or something else? Do we have a front end and back end? Will we need a database? Are there any kind of background jobs? Will the application expose APIs? At this stage, you are just trying to build a technical understanding of what needs to be deployed. You don't need every detail here, but you need enough to design the right platform. Only now we start drawing. A very simple architecture might look like this: internet, load balancer, application, database, storage, monitoring. This is not the final design. It's simply the first draft. It's simply the first draft. Every production system starts on a whiteboard. Not Terraform, not Kubernetes. Architecture always comes first. Now comes a very important decision. Where should we run this application? We have multiple options: Azure Cloud, AWS Cloud, Google Cloud, on-prem, or hybrid. This decision depends on many different factors. For example, company standards, right? Existing skill set, budget, compliance requirements, customer preferences, existing infrastructure. There isn't a universal best cloud. The right choice depends on the project to project. Once the architecture is agreed upon, the real development begins. The team creates the source code repository using tools like GitHub, GitLab, Azure DevOps, Bitbucket. Now we define the repository structure, right? Followed by branching strategy. Then access permissions, code review process. Everything is version controlled from the very beginning of the project. Now we finally start creating the infrastructure. This is where infrastructure as code tools like Terraform become useful. Instead of clicking around the cloud portal, we define everything in code. For example, we try to create virtual networks, we try to create subnets, we are going to create some storage accounts, we try to create some databases, key vault, managed identities, monitoring resources. The entire environment becomes repeatable and consistent. The developers are writing code every single day. But how does that code reaches production? This is where CI/CD comes in. Every code change automatically triggers a pipeline. A typical pipeline might build the application, run some automated tests, perform security scans, build a Docker image, push it to a container registry, deploy it to targeted environment. The goal is very simple here. Reduce manual work and reduce human errors. One of the biggest mistakes engineers make is treating security as something to be added later. In production, security is part of the design from the very beginning. Think about RBAC, role-based access control. Think about managed identities. Think about secret management. Think about network isolation. Think about encryption. Think about audit logs. It's much easier to build security into the platform than to bolt it on later. Before users start using the application, ask one final question. How will you know when something goes wrong? Every production platform should have centralized logs, metrics, dashboards, alerts, health checks. If you can't monitor your system, you can't reliably operate it. Did you notice something interesting? We spent almost this entire video planning before deploying anything. That's what surprises many engineers. DevOps isn't just about Docker or Kubernetes, and it's definitely isn't just writing Terraform. A DevOps engineer's real responsibility is to understand the business, design reliable systems, automate repetitive work, secure the platform, and make sure the application can run successfully in production. I hope you enjoyed this video. Thank you for watching. I'll see you in the next video.